Well, I've always been interested in marine biology since I was a child. And that's because I grew up in Indonesia and the Philippines. And so I didn't return to the mainland US until junior high. And, uh, and I remember as a child in the Philippines, I was on the island of Zamboanga, which is in the south. And I remember the white sand beaches, and that was life. And so I've never really been away from the ocean. It was pretty obvious that intertidal ecology was doing very well. There were good experimental methods being used in intertidal ecology, and Joe Connell and Bob Payne were leaders in that. But there was a noticeable lack of any theory pertaining to marine systems. And there was a little bit of physical oceanography, but by and large, you could almost look at the marine ecology as being experimentalist dominated, and you could look at terrestrial ecology as being theory dominated, because MacArthur was still alive. And Martin Cody and Eric Pionk and his students were making a big impact. And so it seemed to me that there was a vacuum, or an empty niche, you might say, for some theory that pertained to the rocky intertidal zone. And in Central California, I was at Stanford then, of course, and in Central California, there's a lot of rocky intertidal. Now, so I started working in that system, anticipating that I would develop some theory for it and some modeling. And one thing that became clear right away is that what Bob Payne had been reporting for the Washington coast was not occurring in Central California near Hopkins Marine Station, where I was based. And so cherished concepts like the intermediate disturbance principle and the keystone predator and ideas like this, which were very current and just weren't going on and offshore. And the reason it turned out was that there wasn't enough recruitment of barnacles in particular, or mussels, to occupy the space, the empty space on the rocks. So there'd be empty space left over. And therefore, the barnacles didn't come into contact with one another. And so you couldn't get the emergence of a hierarchical competition system. And without that, then you didn't have a keystone predator effect, because there was no dominant competitor. And that then implied that that the control of the community structure in the rocky intertidal zone rested offshore in the water column processes that were responsible for recruitment, for bringing the larvae to shore. So the fieldwork from my lab was for the most part offshore. We had monitoring stations set up onshore, but then we had little boats, and eventually the NSF boat, where we went offshore and went to fronts and went to locations where the larvae were to be found offshore, and then study the dynamics of the water column that would lead the accumulation of larvae to be transported to shore, causing a recruitment pulse. And so we explained why there were recruitment pulses and what caused them, and so forth. So that was the best, I think the best empirical work I did. I did empirical work with lizards showing that there was present day competition between the anoles that depended on the difference in body size. And at the time, that was important to do. It was experimental, and there wasn't a lot of experimentation going on in terrestrial community ecology. Just as I say, just the flip side of what was happening in the intertidal zone. So I sort of did experimentation in the terrestrial zone, and I did theory in the rocky intertidal. And so that's the long story.